Following on from the previous two videos, we were trying to maximize our volume, and this here was a condition placed upon us by the post office. In the past, we would vary x here. We would make x big, or we would make x small. We would vary x. In this video, I just want to show you that you could also vary L. It doesn't always have to be x. It could be L. So in the past, we would produce a graph of the volume, and then here we would vary x. So here we would vary x. But in this video, I just want to show you that you could, if you wanted to, vary L. So you could vary L here, and then see what happens to the volume as you vary L. Okay. So start out with this. So the volume is still x squared times L. This is a condition placed upon us by the post office. So now we are trying to work with this here, because we want to, in a way, draw a graph of V versus L. Okay, but this is your condition placed. This is a condition placed upon us by the post office. So rearrange this to make x a subject. Okay, make x a subject, and then put this into here, because ultimately we want to produce a graph of V versus L. Okay, so make x a subject, and then put this into the x. Okay, that will then take us to here. That will then take us to here, and then now it's a bit hard to sketch this graph. Looking at this, it's a bit hard to sketch a graph. So multiply out the brackets here. Multiply this out. Okay, multiply this out, and then it's blah blah blah. It will then get to this stage here. Once it's in this form here, we could sketch our graph now. So when so looking at this here, this is like you sketching a graph of y equals a constant x minus a constant x squared plus a constant x to the power of 3. So this is like you sketching a graph of y equals x to the power of 3 minus x squared plus x. So when given this here, when x is small, it wants to do this thing here. It wants to do a straight line here. When x is big, it wants to do a positive cubic. It wants to do a positive cubic. So it wants to do something like this, but only when it's big. So only when it's big. So it wants to do something like this. And then you've got a slight negative quadratic. So maybe do something like this, and then your graph will look something like this. Maybe. Okay, it will look something like this. Well, anyway, once so build this graph in your mind. So your graph will look something like this. Okay, it might not even cross into the negative realm. It might just be this. Hang on, it might just be something like this. Okay, like this. Sorry. So by looking at this here, you can have a mental in your mind. You can have a mental image of this graph. So it looks like this. As it turns out, that it actually looks like this. Okay, so in the previous video, we had a function v. In the previous video, we had a volume as a function of x. So in the previous video, it was the volume as we vary x. Now in this video, we are varying L here. So the graph here, so the volume here is a function of L. So as we vary L here, the graph looks like this. And bear in mind that remember in the previous video it was L equals 2x, meaning that your box here will have to be half. The width here has to be half the L here. So notice that this here is half of this here. Okay, so this, well, the graph now looks like this. So the volume as a function of length is given by this blue line. The volume as a function of x is given by this. The important thing to notice is that this is half of this. Well, anyway, let's pretend we didn't have this graph. Okay, so going back to here, we are currently at this stage here where we have the volume equals this. So we basically just want to know where where the gradient will be 0. So so differentiate this will then give you this, and then set this to be 0. Okay, so that will then take you to here. So so now, hang on. So now now it's just a matter of solving this this equation here. So use whichever method you want. Use a quadratic equation if you want to, but it's just a matter of you solving this quadratic equation now. So it's blah blah blah. Okay, blah blah blah. Use whichever method you want, and then L turns out to be this. Okay, so this whole thing here is this point here. Hang on. Hang on. Is right at this point here. So that's that L there was right here. Okay, which happens to be this. Okay.